Go.
Alright, okay, Stanley. What we got here, okay, we're just going to focus on number 61 for right now. This is chapter 21. We're talking about electric charge, okay? So just pick up from where we left off. Okay, I'm just going to read the problem just to refresh so that we know exactly where our standing is. Okay, so we have 2-point charges, 30 nanocoulombs, and negative 40 nanocoulombs. They're held fixed on an x-axis, okay? So you have to visualize, make visual pictures so that you can keep note mentally of what is taking place, okay? So, on an x-axis, fixed on an x-axis, there's no other components, no vertical components, there's no third dimensions, we're just talking 1D, one dimension, okay? So, at the origin, they're at the origin and at x equals 72 centimeters respectively. A particle with a charge of 42 nanocoulombs is released from rest at x equals 28 centimeters. In the initial acceleration of the particle, if the initial acceleration of the particle has a magnitude of 100 kilometers, that is, per second squared, what? Tell me what is the particle's mass? So basically, it's a very simple problem, and they just like to trick you. They like to, trick you with all kinds of words and phrases and BS, basically, bull. But we can get past this together. All we have to do is just dig a little, not a lot, just dig and search and define what it is that we are looking for. So what are we looking for? Is the alternative, it's the question at hand, really. So we are looking for the mass of the particle, and we know, remember Newton's second law, force equals mass times acceleration, Stanley. It is Stanley. I gave you that new math name. Force equals mass times acceleration. So if you're looking for the mass that gives you the initial acceleration, all we have to do is calculate the forces that are acting upon this third charge. And this charge, the way that it comes into play is the charge, and here are the axis of one charge here and one charge here. And this third charge comes, and it says it starts at 28 centimeters, and it goes from 28 centimeters to 72 centimeters. So you have the new distance, the new radii. So we get some new variables coming into play, and this is very exciting. It just gets me going because it just thrills me to think of these two charges and then a third charge, and then it's like a detective. I feel like a detective slash rock star slash Tracy, because I'm Colombo, all your, Matlock. I feel like a modern day Matlock with these physics problems. Because what you do is you're given these clues. These are clues. Sherlock Holmes. Clues to finding the truth. Do you want the truth or do you want to lie? I prefer the truth. And basically, all we have to do is just look and see what is it asking for. And all you have to do, okay, I have this little diagram here. You can see. Here's the charge 1, here's the charge 2, and you have the various, the magnitudes of these charges, okay? And you have to say, what is acting on this